Today we are going to talk about pandas operations, and as you can see that I have imported both numpy and pandas so that I can create data frames out of that df of call1, and I can just directly say here dot apply, and I can pass here a lambda function. So I will say here lambda. That can happen using a pivot table. Understood? So to create the pivot table, I will write a command here df dot. I have a command called pivot table. Hey guys, welcome to our channel Code is Akib. This is Ashank David, and in today's video we are going to talk about pandas operations. As you can see in this case, I have already created this workbook called pandas operations for you, and here we are going to write all our commands related to all the types of panda operations. So let's get right into it. Now, before I start this video, I would like to request you people to please like, share, and subscribe to our channel Code is Akib, and don't forget to press the bell icon so that you won't miss any future updates. So that's it. Let's start. So in our previous video, we were talking about merging, joining, and concatenation. So if you haven't watched that video also, I'll give the link in the description below as well as in the I button so that you can go ahead and watch that. Now, without any further ado, let's get right into the topic, guys. So let's quickly see. Today we are going to talk about pandas operations, and as you can see that I have imported both numpy and pandas so that I can create data frames out of that. And I have already written one example of data frame df here, which we are going to see in a moment. If I print this df, you can see that it prints nice data frame like this. Okay. Now in the next thing, let's say you want to do some operations onto this data frame, this example data frame. Okay. What kind of operations you want to do now? You can do different operations like apply, where you can apply different functions, inbuilt functions or user defined functions, those kind of operations. You can apply functions onto a data frame, or you can directly create something like you can count the number of unique variables, unique numbers into unique elements into your data frame, or you can count, or you can check out how many unique data. There's so many things you can do. We will see all of them one by one. So the first operation that I'm going to tell you about is finding the unique one. So let me just quickly write here, finding unique data into your data frame. Okay. So it's finding. Okay. So now let's do that quickly. Let's say we have this df, the above df, and in this df, let's say I want to find the unique data into column number 2, because here you can see that we have multiple repeated datas here into our column 2, right? Let's say I want to find the unique values here. That means those values which are not getting repeated. In this case, it should be 444, 555, and 666, but not this repeating element. So to do that, I am going to specify that using my df, and here in the square brackets, I can pass the column name call2, and then I can say here dot, I can say here unique. So as soon as I say here unique, unique is a function, and once I do that, you can see that it returned us 444, 555, and 666 according to what our need was. It did not repeated the duplicate elements, which was 444 in this case. So it only gave us the unique elements out of that particular column inside this data frame. I hope this is very much clear. Now let's say you want to find out how many unique data is present into that particular column, maybe 2, 3, 4, or 5, and so on. You can use the length function. So something like this you can write here, len of. Inside this len of, I can pass this whole thing, right? I can pass this whole thing. And after that, I can run this. It will return me this 3, correct? But here, we have a dedicated function which is going to do this job. So rather than you using this len function again and again and giving this whole inside that, instead of doing that, you can just say here the column, the same thing. And instead of just saying unique, you will say n unique, which is going to give you the same result, the same output. So you don't have to use this len function anymore when you are using n unique, which is going to give you the unique data frame, unique elements out of that data frame. I hope this is very much clear. All right. Next, let's say you want to count the unique data again and print all the unique data into that into a form of a series, Panda series. How you can do that? So you can say something like this, and instead of just saying unique, you have to say value count, value underscore counts, which is going to give you all the unique data, and it will also print it in the same way. I hope this is very much clear. So this is one type of operation that we can perform on data frame. We will see more of them. Let's see. The next operation is going to be your selecting the data out of the data frame. Okay. We have already done this before. I am just going to give you a quick revision of what was this from our previous videos. So if you haven't watched our previous data frame part 1, part 2, part 3 video, I can give you the link of that also in the description. A link is already given in the description, by the way, and you can go ahead and watch that video also. But in this case, quick revision of what we did there. So selecting data, if you want to do, let's say I have this data frame and you want to select some particular data using conditional selection. What you can do is you can say here df of, you can pass the df of that particular column name or something there. So something like this we can pass, and I can say here greater than or less than, depending upon whatever you can pass that variable, that number, and it is gonna give out that particular thing in that case. So all the numbers are greater than 2 here. So it printed all the values here like this. Understood? For column 2. So it gave us a data frame where in the column 2 of the data frame, all the values are greater than 2. If you say less than 2, then nothing will be there. So you can see that and any element is not less than 2 in that case. So this is what you call as conditional selecting. So I'm giving this right here and making that again. Let's say you want to pass multiple conditions. What you can do then? You can say df of, and here inside this, you can pass multiple conditions in square in round brackets using either an operator or operator. So in this case, I can pass two conditions like this. And here I can pass the first condition, let's say df of, let's say call to, that means column 2 is also greater than 2, and the same thing I can say here also equals to, let's say maybe 444. Okay, so it will only give us what data? It will only give us one particular column. Let's see what it is going to be giving. So you can see that data with only 444 has been selected out from this and this, right? From this and this. And the value is greater than 2 for column 2. Both the values 444 and 444 are greater than 2 in this case, and that is the reason why it printed this. I hope this is very much clear to all of you guys. Now, this is going to be our second type of operation that I have done. Next thing is we are going to learn about is going to be apply method. Apply method. What is this apply method? Well, apply method, if I tell you in a nutshell, apply method will allow you to apply any type of function or third-party function or built-in function into that particular data frame. You can attach it. Now, for example, let's say I have a function def times 2. If you remember this function def times 2, and we passed here x, and inside this I can just say, let's say the return the times 2 of this x. So into x into 2. Okay, which is gonna be like this. So this is gonna be our function. I have not given this. Okay, so yep, like this. Okay, so this is your function, and let's say we have this function and I want to apply this function into some data frame. Okay, so for example, let's say we have df of, I have call 2 or call 1, whatever. I can say dot sum. We have call 1, right? 1 2 3 4, right? I can apply this dot sum method, which is a, you know, inbuilt function. Understood? Inbuilt function. You can apply that like this. But let's say you want to apply a third party function like this onto this function. How you can do? You can say here the same thing, df of call 1. You can say like this, and you can say dot, you can say apply, and here you can pass the whole function itself. What is the name of this function? Times 2. So I can just copy paste it here. So times 2 will be applied here into this particular part, and you will get this output 2, 4, 6, 8. So in the column 1 of this data frame, 1, 2, 3, 4, I got 2, 4, 6, 8. I hope this is very much clear. So 1 into 2 happened, then 2 into 2 happened, then 2 into 3 happened, and then 4 into 2 happened. And this way we will get the times 2 function applied to column 1 of our data frame df, this data frame. I hope this is very much clear. Now, not only apply function will work with all your third-party functions, but also your apply function allows you to, give any inbuilt function as well. So you can use inbuilt functions also. Okay, so that can be done here in this case. Okay, let's do some other operations using apply functions. Let's say you can quickly, let me show you how it works. So let's say I'm applying this len function. Okay, len function is not working because my column number is wrong. Let's say column 3. So column 3 is giving me the length of the items that we have. So the length of the item. So this is 3 digit, this is 3 digit, this is 3 digit, this is 3 digit, right? So it is giving me 33333. Okay. So this is this is a inbuilt function, right? So this is how you can apply an inbuilt function also. But one more thing I would like to just tell you, which is a good practice, that if you want to apply a custom made function like this only one time, and you have to use only it for one time, then you can convert that function. Rather than creating a dedicated function for it, you can create a lambda function for it, and then you can apply that into the apply function. If you want to use it once, you don't have to declare a function like this and then say times 2 using apply in a particular data frame. You can directly do something like this. So say suppose I want to do it this in df of call1, and I can just directly say here dot apply, and I can pass here a lambda function. So I will say here lambda. I'm going to write the same lambda function for the same function. Here I'm going to write x of x into 2, which is going to be the lambda function for times 2 function, the same function that I have written here. This is the same function here as well. So that's the lambda function of times 2, and we can get the same output like this. So if you want to apply a particular function only one time into a data frame, rather than declaring a function differently and then applying it using its name, you can apply it using a lambda function, and once it will work, and you don't have to declare the function always all the times again and again. I hope this is very much clear. Okay, so this is one thing that you do. This is your apply function. Okay, then how do we remove the next operation? Let's quickly see. Let's say we have this data frame. Okay, let me add one more line up here. Let's say removing columns or rows. Okay, let's say we have this as another operation, removing columns. If you remember, how do we remove the columns? We use drop, right? So if I say here df dot, I can say drop, and I can pass here what? I can pass the column name if I want to drop. So let's say I want to drop, let's say call1. Right now it is going to give me an error. Why so? Because there is no row named call1. If you remember in the signature here, if I open up this signature, you can see that it contains axis also. Axis is set to 0. 0 means by default it is representing the row, not the column. And it can't find call1 row. That is why you have to manually say axis equals to 1. And then you can delete the call1 from that. And this is how you can do it. But remember that this is not permanent. This df will still have call1 because you have not said in place equals to true. If you remember from our previous data frame part 1, part 2, part 3 videos, we have understood this very well there. I hope this is very much clear. Okay. So if you don't say axis, or if you say axis equals to 0, it will remove the row. And if you say axis equals to 1, it will remove the column. So I can write here removing column and rows. Okay. So this is your another function here that we have applied, operation, type of operation. Okay, now next type of operation is what happens if you want to sort or sort, you can say sorting and ordering the data frame. If you want to do sorting or ordering of a particular data frame, how you can do that? Let's say we have this data frame, the data frame that we have created. Now in this data frame, you want to sort the values. Okay, so what you can do is you can say here df dot, and here you have a function called as sort values, and there you can pass the column name, or let's say call one. So if the call one is there, the values will be sorted. But here the values are already sorted. I need to, let's say, sort this column 2. So we'll pass column 2 and pass here again. And you can see that 444, 444, 555, and 666, these values are sorted. And we have got the sorted values. Now, if you want to say, if you want to check a particular data frame contains a null value or not, what you can do? You can say df of df dot, and you can pass is null. This is a function which gives you a boolean data frame where it will show you which data element is null. If there is any null data frame there at that position, it will return you true. But in this case, in this data frame, there was no NaN value or missing data. You are getting a false boolean data frame. I hope this is very much clear. You can pass is null, and wherever the null values are present, there automatically it will show you true in the boolean data frame form. I hope that this is very much clear to all of you. Last thing of this video that I would like to tell you, and which is one of the most important and the most complex part that you will see right now here, and that is going to be pivot tables in pandas. I can say here pandas pivot tables. Now, what is this pivot table? So if you remember, in Excel, we used to create pivot tables. What is a pivot table? A pivot table is a table which will give you a quick summarized look of a particular, lot of data. Let's say you have a data of, let's say 5,000, 6,000 rows, and you want to summarize that in one single small table, in one summary table. Then you can create a pivot table. So pivot table is just like that only, where all the values are stored into one place in a summarized way. This is what pivot table does. So let's see how pivot table works in pandas. So let me first write a example data frame for it, and I'll get back to you. Okay, so this is our data frame, and I have created this data. I have created this dictionary, and I have created this data frame. Data frame is equals to pd.data frame, and I pass this data. So if I run this code right now, it won't print anything because we have created the data frame, but I need to print the data frame also, right? So I'll print the data frame df, and you see that this is our data frame. Okay, now I want to apply a pivot table where this table can be converted into a summarized way where everyone can just look at that pivot table and you can just understand what was happening in this case. So you can see that there are, six rows starting from 0 going till 5, and in every row we have repeating columns with repeating elements like foo, bar, 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 1 1 1 2 2 2, x x x, y, 1 2 3 1 2 3 1 2 4 5, like this. These kind of elements are getting repeated, right? I want to summarize this into one form where if there is one here and there is one here, I can get to know that not only in 0th column but also in the 5th column, in the 0th row and the 5th row, we have one in the dth column. And let's say we have x in the C0 and x in C2 and x in C4. So I can get one table where both C and 0, 2 and 4 are kept in one place. So I can understand how the x is where all the x is getting printed on and how many occurrences of x is there. That can happen using a pivot table. Understood. So to create the pivot table, I will write a command here df dot. I have a command called pivot table, and I can say here pivot table, and inside this, let's see what is the signature of this pivot table. So if I open this up, you can see that it is taking the value, index, column, aggregate function if there is any, fill value, margins, drop NA, and margins, and observed, and sort. So there are so many things that you can write inside this, but we are gonna use what all things we are gonna use its values, index, and columns most of the time. So let's say we have values equals to, I can pass, let's say a value can contain any particular row or a column. So I am passing this D, for example. I'm passing this D. Okay. I'll pass the index of that and I'll pass the column as well. So I'm going to pass here comma index equals to, let's say index is going to be the list of the columns in total. Go into dth column, match it with A and B, and get the values of, let's say, column C, like that, if I want to do something like that. So what I'll do is I'll say here index is equals to, make the index as A and B. Okay, and at last, columns will be specified as, let's say, the columns will be of column C. Okay, I've given something like this. Okay, now I'll hit the enter and you'll see that I have got the repetition of the elements from A and B. A and B, you can see that 1, 2, 1 is coming from B and foo and bar is coming from A, right? So bar 1, 2 from A and B, and in the Cth column we have X and Y, right? X and Y. So you can see that I can tell that 1 and 2 is getting, it's coming 1 and 2 for this Cx, understood, and 0, then 2, and then 4, like this. It is getting the data from it. And you can see that in 2, we have this. 2 is getting repeated for Y values. So X and Y values are getting added into that. And the values are taken from actually D. So you're getting the average of all of that and foo 1, and you can see that the values are getting calculated by this column D in this case. So well, this is how you can do pivot tables in data frames. I hope this is very much clear. Okay, so this is one of the operations that we are gonna learn about in pandas, and that's it for this video, guys. All of these functions I have told you, these are just some of the pandas operations that we are looking into, and that's it. We have done unique data, selecting data, apply function, removing columns and rows, sorting and ordering, and pivot table. Okay, pivot table is a little bit complicated to understand, but it is used sometimes, not always, but it can be used in many places. So we may or may not use in future videos, but there is, it is there to tell you. So that's it. These are some of the operations that we are going to be doing in future videos in pandas, and these are the most common ones. So that's it for this video, guys. I hope you have liked this video. If you have liked this video, give us a thumbs up, and if tell us in the comment section what you felt about this video. If you have any doubts, tell us in the comment section as well, and we are gonna get back to you guys very soon. Don't forget to like, share, and subscribe to our channel Coders Arcade also. And that's it for this video, guys. Thanks for watching. This is Ashang David signing off. I'll see you guys in the next video.